Okay, so for number 11, this is a complex problem from chapter 1, parallel lines cut by a transversal. So we're going to need, in this problem, we're going to need a few of our theorems from parallel lines cut by a transversal. Let's see. So what I'd like to do with these is it's just too complex looking at it the way it is, and there needs to be an adjustment here. Something went wrong in the equation or the setups. That needs to be 2x plus 5. So go ahead and switch that on your problem. If you don't, you're going to get two different values of x for the same problem, and that doesn't work. It's possible they meant for that to be z. I don't know, but let's make sure that because it is x, we're going to have to say 2x plus 5. All right, here's what I would do. I would try to isolate one transversal at a time, and I want to show you what I mean here. This is a transversal cutting across parallel lines, but this one is a different transversal. So we got two different transversals, two different problems essentially going on here. So I am going to start, let's just start with this one here. So I'm going to try to sketch that again. Now I know 124 in there, and what I'm going to do first is to make this a lot less difficult is I'm going to go ahead and do 180 minus 124 to get 56. What I like to do is this 124, use vertical angles there, use linear pairs to get 56. Now I'm going to jump over to the other intersection. And if these lines are parallel, basically the other intersection is going to have the same exact measures around it, 124 and 56. So same positions, right? None of those really help us except this one. You see this one's got another line coming through it, so we can't use those. Yeah, the 56 it really isn't. That's here, but it doesn't help us. It's this one right here that helps us. What we know now is the 3x minus 7 should equal 56 from there. So what we're going to do is we're going to get x. So 3x equals 63, divide by 3 to get x is 21. Okay, so now of course we could use that to get this one, and then eventually we'll be able to find y. All right, looking at the other intersection, so, or other transversal, I should say. So now we're looking at this one. 133 here, pretty much the same process. So we've got on this bunch of, whoops, wrong spot for that one. I'm sorry about that. The 47 should go there, 133 there, 47 here. And then look at the other intersection again because these are your parallels. Same positions. Oops, 133. And then let's see if any of those help us. Ah, jeez. All right, come on. Okay, let's see if any of those help us. Let's see, definitely not this one because it's got an angle or a segment coming through it. Yeah, this didn't help us much. We already know what x is, so we knew that was going to be 47 anyway. So let's go ahead and go back to this parallel lines cut by a transversal again. Let's put both of the transversals in now. What we know is that this one's 47, this one's 56, and then this one's 3y plus 5. So one last concept is we have a straight angle all the way from here to here, which that means that those are going to add up to 180. Okay, so we're going to get 3y whoops, plus 108 equals 180. And then subtract 108 from both sides. 3x equals 72. Divide by 3, and we should get, whoops, that's a y. I apologize. Going too fast here. So we get y equals 24. And is there anything more that they want to, just to double check? Just solve for the values of x and y. Okay, there it is. Good. Another chapter 2 concept, geometry basics, distance. Okay. So origin to negative 8, 6. Okay. Let's see, P, and this is the origin. Now, they want you to use distance formula. If they ever give it to you, it looks like this. We're not going to use that, though. We just use Pythagorean Theorem. Okay? Basically, your x1 minus x2 is this distance, which is 8. Your y1 minus y2 is basically this distance, which is 6. And then d for distance. Okay, so we're going to use Pythagorean Theorem instead. 8 squared plus 6 squared, right, equals d squared. Only works for right triangles, which is what we created there. 100 equals d squared. Square root both sides. And the distance from origin has a distance of 10. Okay. All right. Another one, we got time for that. So, all right. Measure of angle 3 is what we're looking for. Okay, it does say they're parallel. We can't assume that, but that since they gave it to us, we're good. All right. So this is a little strange right here. This position and this position, there is no angle pair on the parallel lines cut by transversal. There's no angle pair that these directly are. One's on the interior, one's on the exterior. They're not in the same position. They're on other sides of the transversal, so none of our typical names work. However, angle 3 and angle 2 are corresponding. Angle 2 and angle 3 are corresponding. What that means is we know that they are equal. If we know they're equal, angle 3 can get the expression 3x plus 12, so they're corresponding. Now we can use linear pair, right? We know they add up to 180. We can use the linear pair concept to finish it off. So we did use corresponding angles on parallel lines cut by transversal, and we will use linear pair. So we're going to say 3x plus 12 plus 2x plus 13. That equals 180. And now it's a matter of combining like terms and go through your process of solving. What is that? 155. Looks like 31 maybe. So there you go. Oh, wait a minute. No, they want the measure of angle 3. Sorry. Yeah, be careful. Make sure we actually go, solve the problem they want. So they want the measure of angle 3. So now we're going to take 3x plus 12, plug it in. 93 plus 12 looks like 105. Yeah, 105. Okay. All right, GI bisects angle BGH, and AB is parallel to CD. GHI is 44. Okay. Find the measure of BGI. They want this. Okay. BGH is bisected. So let's try to break this problem down. What we got going here is if we look at BGH, one thing that's happening is those two are the same. Interesting. Oh, okay, here's what we can use. If we focus on this, if we got a 44 there, we can do 180 minus 44 to get 136. That's consecutive interior angles theorem, or again, we can go back to the concept I showed you in the last problem with parallel lines cut by transversal. You can figure out the rest of these and then go up to the other intersection, and all of the angle measures should be the same positions. Okay, now since BGH is 136 total, and it was bisected, we're going to take 136 divided by 2, and we should get 68 apiece here. Let's see if that does anything for us. Yes. Okay, so we also, oh, wait a minute, that's it. That's what we wanted, BGI. BGI, yes. So that's going to be 68 degrees. Okay, good enough for that one. Just double checking here. Yep, looks good. Okay. All right, that could be enough for this video, and what we'll do is we'll pick up on the next one.